गुड आफ्टरनून ऑल ऑफ यू। तो हमने जो है पिछले लेक्चर में सल्फर इलाइड के टाइप्स, उसका इंट्रोडक्शन और उसकी प्रिपरेशन देखे थे। आज जो है हम स्टेबिलिटी एंड रिएक्टिविटी ऑफ सल्फर इलाइड और सिंथेटिक एप्लीकेशन ऑफ सल्फर इलाइड जो है देखेंगे। ठीक है, फर्स्टली वी विल सी स्टेबिलिटी एंड रिएक्टिविटी ऑफ सल्फर इलाइड। We know that sulfur ylide are of two types. First one is sulfonium ylide and second one is sulfooxonium ylide. Okay, these are the two types of sulfur ylide. Now the general structure of sulfonium ylide is like that. Okay, and sulfooxonium this is the general structure of sulfooxonium ylide. These are the two types of sulfur ylide. Okay, when we observe the structure of sulfooxonium ylide, we know that it have a negative charge carbon atom. It acts as a nucleophile. Okay, and the negative charge of the carbon is stabilized with sulfide bond. Okay, it means it delocalize with sulfur oxide bond, and we will get this type of another form of sulfooxonium ylide. But still the sulfur bear a positive charge. It means here the availability of lone pair is decreases. Hence it is stable but less reactive. Okay. On other hand, when we observe the structure of sulfonium ylide, here also negative charge present in the carbon atom, but this negative charge is stabilized with vacant orbital of sulfur. Here one vacant orbital present on sulfur, and here we will get this type of stabilized form of sulfonium ylide. Here lone pair will be regained sulfur. It means here availability of lone pair is occur. Hence it is most reactive but less stable. So the stability and reactivity are depends upon the types of sulfur ylide. First type is sulfonium ylide and another type is sulfooxonium ylide. In case of sulfooxonium ylide, availability of lone pair is decreases, means it less reactive but more stable. On other hand, in case of sulfonium ylide, here availability of lone pair is increases, hence it is more reactive but less stable. Okay, so this is the simple stability and reactivity of sulfur ylide. Now the another topic of the today's lecture is synthetic application of sulfur ylide. we know that sulfur ylide have two types. First one is sulfonium ylide and second one is sulfur-oxonium ylide. And these two types are mostly used in the organic synthesis. Okay. And the substrate generally used in sulfur ylide, carbonyl compound, and second substrate which are generally used in application of sulfur ylide is alpha beta unsaturated compound. Okay, these are the two substrate molecules generally used in application of sulfur ylide. It means the sulfur ylide will react with carbonyl compound as well as alpha beta unsaturated compound and to form epoxide and cyclopropane compound. So there are two mostly used synthetic application of sulfur ylide is formation of epoxide and formation of cyclopropane compound. We will see both one by one. The first application of sulfur ylide is formation of epoxide. Formation of epoxide. Okay. How to prepare it? Now listen. When the aldehyde and ketone is react with sulfur ylide to give epoxide. When aldehyde or ketone is react with sulfur ylide to form epoxide. Okay. Here the substrate used carbonyl compound like aldehyde and ketone, and generally the sulfur ylide used in the form of unstabilized sulfur ylide. Okay. Now let's see here. This is our carbonyl compound. This is the first substrate molecule and unstabilized sulfur ylide is the another substrate molecule. It reacts with carbonyl compound and form epoxide. Okay, so this is the general representation of formation of epoxide when carbonyl compound is treated with unstabilized sulfur ylide to form epoxide. Okay, now what will happen here? Now see here, I am taken here this type of carbonyl compound. Okay, here I am taken unstabilized sulfur ylide. Okay, this is the types of unstabilized sulfur ylide because of here CH2 CH3 is a electron donating group, so it is the types of unstabilized sulfur ylide. What will happen here? The negative charge carbon or nucleophile of sulfur ylide attacks on an electrophilic carbon atom of the carbonyl compound. Simultaneously, the bond between carbon and oxygen shifted toward the oxygen, and we will get intermediate called as bitan intermediate. Now see here, okay, this carbon, negative charge of the carbon attack on this carbon atom. Now see here carbon, okay, carbon have one hydrogen and one methyl group. Also it have sulfur positive and it have two methyl group. So this is our bitan intermediate. Okay. In the formation of epoxide, firstly carbonyl compound treated with unstabilized sulfur ylide to form a bitan intermediate. These bitan intermediate undergoes SN2 type reaction. SN2 reaction. And to form epoxide as a major product. Now see here what will happen here. The negative charge of the oxygen attack on this carbon. Simultaneously, dimethyl sulfide will be removed and we will form let's see here, this negative charge attack on carbon and to form our final product epoxide. Also here dimethyl sulfide byproduct will be formed. Okay, so this is the formation of epoxide. What will happen here? Carbonyl compound attack on unstabilized sulfur ylide to form bitan intermediate. This bitan intermediate undergoes SN2 type reaction to form epoxide. Okay. This is the first application of sulfur ylide, formation of epoxide. Okay. Here I am taken normal carbonyl compound. It is known as cyclohexanone. Okay. Suppose if here the substrate molecule is alpha beta unsaturated compound, so what will happen here? Now see here I am taken alpha beta unsaturated compound. Okay. Now see here, this is our functional group and it is alpha position and it is a beta position, and alpha and beta position have a one double bond with means unsaturation, so it is called as a alpha beta unsaturated compound. Okay, this is the structure of alpha beta unsaturated ketone. If the substrate molecule is alpha beta unsaturated and it reacts with unstabilized sulfur ylide, this is the unstabilized sulfur ylide. It also gives the formation of epoxide. Now see here in the first step, this negative charge of the carbon attack on a carbonyl compound to form a bitan intermediate. This is the first intermediate called as bitter intermediate, and this intermediate undergoes into SN2 type reaction and form epoxide product. This negative charge acting on this carbon atom simultaneously dimethyl sulfide will be removed and form epoxide. Okay. Now listen, if the substrate is simple carbonyl compound as well as alpha beta unsaturated compound is react with unstabilized sulfur ylide to form epoxide. Okay, so this is all about the preparation of epoxide and the first application of sulfur ylide. I hope you will be understand better. Now the second application of sulfur ylide is formation of cyclopropane compound. We will see it. Okay, the second application of sulfur ylide is preparation of cyclopropane compound. Okay, now listen, what will happen here? If the substrate molecule is alpha beta unsaturated compound is treated with stabilized sulfur ylide to give cyclopropane compound. Okay, when the substrate molecule is alpha beta unsaturated compound treated with stabilized sulfur ylide to form cyclopropane compound. Okay, if the compound is substrate is alpha beta unsaturated compound treated with stabilized sulfur ylide to form cyclopropane compound. This is the general representation of formation of cyclopropane compound. Okay, now the first substrate is alpha beta unsaturated compound and the second substrate is stabilized sulfur ylide. Okay, now see here, I am taken here I am taken okay this type of alpha beta unsaturated compound. Okay, here alpha and beta position have unsaturation, so it is called as alpha beta unsaturated ketone. Okay, it react with stabilized sulfur ylide. So here this is the stabilized sulfur ylide. Okay, we know that dimethyl sulfooxonium methylate is also stable. Okay, so this is the types of stabilized sulfur ylide. What will happen here? This stabilized sulfur ylide act as a soft nucleophile. nucleophile and it attack on a beta carbon atom of the alpha beta unsaturated compound instead of sulfide bond. Now listen, the stabilized sulfur ylide act as a soft nucleophile and it attack on a beta carbon atom of alpha beta unsaturated compound instead of carbonyl compound of the alpha beta unsaturated compound. Okay, so in the first step, this soft nucleophile attack on a beta carbon atom of alpha beta unsaturated compound, and this double bond is shifted here, and this double bond shifted toward the oxygen, and we will get first intermediate called as bitter intermediate. Now let's see here. This is the biotene intermediate. Okay. After the formation of biotene intermediate, this intermediate undergoes acid to type. Okay. What will happen here? See here. This negative charge shifted between oxygen and carbon, simultaneously this bond shifted towards this carbon atom, and this carbon atom become a negative charge, and this negative charge carbon attack on this carbon atom, simultaneously dimethyl sulfur oxide will be removed, and we will get our final product, cyclopropane product, like that. See here, this bond shifted, this negative charge shifted between oxygen and carbon, so here double bond will be formed. Okay, this bond shifted toward the carbon, carbon bear a negative charge, and this negative charge attack on this H2 group. So here the bond will be generated, and simultaneously dimethyl sulfur oxide will be removed. Okay, so this is our final product called as cyclopropane compound. Okay, now the second application of sulfur ylide is formation of cyclopropane compound. Okay, if the substrate molecule is alpha beta unsaturated compound which react with stabilized sulfur ylide to form a cyclopropane compound. Okay, this is the second application of sulfur ylide. Now here I am taken also one example. Let's see here. Okay, this is our alpha beta unsaturated ketone. Okay, this is our functional group. This carbon atom is called as alpha carbon, and this carbon atom is called as beta carbon. And in between, unsaturation will be present, so it is called as alpha beta unsaturated ketone. Okay, it reacts with stabilized sulfur ylide. We know that. Okay, this group is electron withdrawing sulfur ylide. Okay. When stabilized sulfur ylide is treated with alpha beta unsaturated ketone, it forms cyclopropane compound. Now see here what will happen here. Sorry, here CH single CH negative. Okay, this negative charge carbon atom act as a soft nucleophile and attack on beta carbon atom of the alpha beta unsaturated compound. Insist of electrophilic carbon atom of the carbonyl compound. Okay, so what will happen here? This bond shifted toward this carbon atom, and we will generate our first intermediate called as beta intermediate ylide. See here. Okay, this double bond shifted toward this carbon atom, so this carbon bear negative charge. Okay, this is our one methyl group, and this carbon attack on this carbon atom to form bond CH. This CH have one carbonyl group, and it also have sulfur positive dimethyl group. Okay, so this is our beta intermediate. After the formation of beta intermediate, this beta intermediate undergoes acetyl reaction. This negative charge of the carbon attack on this carbon atom. Sorry, the sulfur is bonded with this carbon atom. Okay. This negative charge attack on this carbon atom, simultaneously dimethyl sulfide will be removed, and we will get our final product. Called as cyclopropane compound. And byproduct is dimethyl sulfide. So this is all about the formation of cyclopropane compound. Okay, this is the second application of sulfur ylide. Sulfur ylide have two application. First one is formation of epoxide, and second one is formation of cyclopropane compound. Okay, how to prepare epoxide? When aldehyde or ketone is treated with unstabilized sulfur ylide, gives epoxide. Okay, this is the statement of preparation of epoxide. And now the second application is formation of cyclopropane compound. When alpha beta unsaturated ketone treated with stabilized sulfur ylide gives cyclopropane compound. Okay, I hope you will be understand better. If you have any problem in this topic, so ask me personally on WhatsApp. Okay,